So, this is a presentation about sFlow. It is a standards-based protocol for exporting information about packets traveling through a router or switch. It's like NetFlow, which a lot of people use. Simple premise. You can't possibly have a tap port or any way to record all of the packets that go through your data, all of the locations, but you may be interested in some portion for statistical sampling, and you may want to gather data. The sFlow protocol was designed by the NANOG Corporation in 2001. They did an RFC for the original versions, and then they haven't done RFCs for updates, but there have been a few new versions since those published. The design of the protocol was intended to overcome limitations of the traditional NetFlow protocol, specifically the fixed header format. Every time you need to add a new type of information, you have to release a new version, and it became difficult for people to support. So it's very flexible, extensible. You can change, add, update new header formats, various things. Like I said, it's intended to enhance or replace Armon, NetFlow, the usual type of things. And there are a few vendors who are very prominent with it, specifically Foundry Extreme and Force 10 are relatively well known for supporting it. Cisco and Juniper, however, do not. They still go with NetFlow. A quick recap on why to use any type of export protocol. You are interested in your protocol port application statistics, you're interested in tracking denial of service, you're interested in capacity planning. One interesting thing that sFlow adds is the ability to do layer 2 support. So a lot of folks use it for analysis on layer 2 exchange points. So you can tell how much traffic is going between any particular member without everyone's gear having to do MAC counting, which a lot of equipment out there doesn't support, or even if it does, it's line card dependent, or it's rate limited, or it's some feature that you lose when you turn that on. So for the exchange point to do the polling is beneficial for everyone. You get a nice web page and it displays how much traffic you're doing to every individual peer. Some folks have rolled this out already. Equinix was, I think, the first, and Lynx and Am6, I know, have followed up with their own versions. And it's proven to be very popular. There are some concerns about data privacy, but in general, folks like it and find it very useful. So here's the sFlow version of the history of flow export, which is probably neither thorough nor accurate, but it shows some of the progression through time of traffic levels and various forms of flow. Like I said, the version that you're probably all aware of is NetFlow, which was Cisco dependent. It's been extended many times, and the latest version is NetFlow v9, which not many people have rolled out from what I've seen, but its goal is to copy a lot of the features of sFlow, whereas sFlow is released much earlier. v9 tries to replicate that with a lot of the extended format. So, basically, the limitations that you are facing when it comes to sampling data is how much data are you going to sample. With traffic rates growing at the rate that they are, it's significantly difficult to get all of the packets or anywhere approaching all of the packets. So there are two methods that are used to reduce the amount of data that you have to monitor. The first is sampling, which is simply looking at one out of every N packet. So, sample one out of every 1,000 packets, multiply by 1,000, and hope for a statistically correct average. And the other method is aggregation, which is to collect all the data but then consolidate it on the device before exporting it. So, for example, say you're not interested in every destination IP of every flow, but say you're interested in destination prefix. You might do the aggregation on the device itself before exporting data, and that reduces load on your collector and load on traffic that you have to export. Usually sampling is the winner, and the reason is you don't have to maintain state. For a lot of networks, complex networks with lots of flows, there just isn't enough TCAM in the world or whatever resource is being used, SRAM, whatever, to track the state to build the flows. So a lot of folks face this on platforms today where if you're trying to track NetFlow, even if you don't want it to be stateful, you can't turn it off and you're going to quickly exhaust your router resources. So the problems with NetFlow, it is originally based as a flow-based system. It was designed so that if your router saw 10 packets about a flow, but before, say, the 30-second export cycle or whatever the case may be, it would summarize that data and export information about that specific flow that requires state. So, like I said, frequent state memory exhaustion. And the sampling that is available is an afterthought. So there's no mechanism inside the protocol, for example, to communicate what the sampling rate is. You have to know what you've configured the device for. You generally can't configure multiple sampling rates across different cards, different architecture types, things like that. And support for all versions and features is sporadic. NetFlow v5 is probably the most commonly used today. That's the generic NetFlow. It doesn't include support for aggregation. That's in v8, which is less commonly used. The most commonly used versions don't support layer 2 information. They're not extensible. And that's something that NetFlow v9 has tried to fix. But like I said, it's an afterthought, and it's basically adapting the features of sFlow back into NetFlow. So the features of sFlow, it's specifically designed for sampling. There is no flow data. There's no attempt to track flow data. And from the ground up, it's built to do sampling. So it communicates this type of data inside the packet and makes it much easier to maintain correct and accurate data. Like I say here, you can configure lower rates for 10 gig cards versus 100 meg cards if you want more data, more granular data inside things that you don't necessarily aren't passing that much traffic. There's currently 23 types of data-bearing message formats. That's extended all the time, but it includes everything under the sun from your generic type of NetFlow information to information about the BGP path selected, MPLS paths, and various things. It fully supports layer 2, it fully supports MPLS and BGP, like I said, and it also supports passing the first 128 bytes of the packet. And that lets you get into a lot more interesting detailed analysis with the header and writing custom code to do whatever you want. And one of the other interesting things that no other NetFlow has that I'm aware of is a push-based counter. So instead of having to go out and SNMP query a box and then get the results back, it will actually push the usual SNMP type data out for each interface. It makes it really easy to collect at a high rate of speed interface data. So it's kind of useful. Said that. It turns out to be very useful. There's a lot of benefits to getting down into the 10 to 30 second range as opposed to like a 5-minute average or whatever. You really see a lot more denial of service. You really see microbursts a lot more. So it's very useful. Lots of people are interested in that. The issues with sFlow. Generally speaking, the issues are all in the design of the protocol. So when I first looked at this thing, I thought, oh, wow, this is bad. It's got some interesting formatting, to say the least, and you can obviously see where they're trying to keep everything 32-bit word aligned. The issue is that you have very inefficient use of space. So, for example, you may have values that are only going to be 1 through 4, like, say, BGP version, and that's going to be a 32-bit value. And then later on, they will have separate message formats where they try to take something that is legitimately a 32-bit value, like, say, if index, and they say, well, if it's less than 24, we'll add in some other 8-bit value at the end, and it results in extra message formats and all kinds of complexity. But fortunately, that's just an issue for the people writing the libraries to parse the packets. The other issue is that, at least in the original V2 and then the V4 versions, there was no TLV encoding. So what this means is you have to know, your parser has to know about every type of packet, or if you receive a type of packet which you can't correctly parse, like someone has added a new protocol or a new export message which you're not aware of, you can't just skip over it. You become desynchronized with the stream, and you end up losing the entire packet and corrupting your data potentially. So that's been at least somewhat fixed in V5. They've gone back and added a few new features. Generally speaking, it's transparent to the end user once you get around it. Then, like I said, there's NetFlow v9, which adds the flexible fields, which is comparable to all the different sFlow format types. It adds the layer 2 information. It adds the information about MPLS paths you may be traversing, about BGP routes, various other enhancements. So it's really intended to catch up to sFlow. And then there's been a recent IETF standardization attempt on IPFix, aka NetFlow v10, which is based on NetFlow v9. They had a couple more things, some enterprise-specific formats, but roughly the same thing, kind of the same features. I haven't played with it personally, so I can't speak to it, but for people that happen to operate Foundry, Extreme, Force 10 networks, you're still going to be interested in sFlow because that's the only thing supported. So even if NetFlow v9 or IPFix get around to adding all the same functionality, it's still interesting stuff. It currently, as far as I'm aware, is only supported by Cisco, and that's v9. I'm not sure what Juniper's plans are for it. It doesn't replicate the push-based counters, which I personally find very interesting. There's a couple ways that you can do this, and I apologize, I had a more current version of the slide, which I don't have here. The folks at AMSIX had worked hard to develop their own tools, and I wasn't able to get any information on whether that was officially released or not, but you may want to harass Niels. There's the official sFlow site. There's a reference collector that they give away for free. There's commercial products that they sell. Obviously, it was written and developed by a commercial company. There's some specifications online for the actual protocol. And like I said, and I'm not sure if the AMSIX tool has ever been released, but they did their own stuff. Actually, Niels can tell me right now. Well, maybe not. They probably have to turn it on. Anyways.
It's called Net sFlow, and it's on CPAN.
Okay. So I also, for the purposes of this, worked on another implementation, which is my own high-speed C library. I split this up into two packages, one which is the generic library, which anyone can use to parse the packets, and it's fairly efficient given the limitations of the protocol. And I also split it up into a reference example code. I'm sorry, right now the documentation isn't that great, so if you know what you're doing, you can probably figure it out. If you don't, you may be confused. We'll try to get around to adding more documentation shortly, but there is a reference collector which implements the two most interesting features that I'm aware of, which are the push counter information, writing that out as the equivalent of replacing SNMP polling, and the layer 2 MAC to MAC address mapping. So anyone that runs an exchange point that's interested in sFlow data is probably going to be very interested in this. It's the kind of thing that users seem to like. That's basically the gist of it. So questions?
Hi, Chris Whitfield, Internet. Also, in your list of applications supporting it, I wanted to add that the latest versions of NTOP also will collect sFlow, although I think the latest release version has a bug that breaks sampled sFlow. But there's an RC that was released today that fixes that bug.
Okay.
Matt Ringel, Tufts University. One thing I was wondering about with sFlow is, so you could not actually construct total traffic passed by just taking a look at all the sFlow samples. I mean, yeah, there's plenty of other ways to do it, but you could not do it using sFlow specifically.
Right, you can't, well, you can reconstruct the total data. One of the fields that it does pass is the amount of data that was originally there before it was sampled. So more than just knowing about the packets, if you happen to get, for example, your 1 out of 1,000 packets happen to be the small packet, it still has the counters for the original data that was sampled from the 1,000 packets. So you can at least reconstruct total utilization from that.
All right, thank you.
Anyone else? Well, I think we're good.